Alright, well, we're starting up the math videos after a week. I'm changing up the format a little bit slightly. This is the book we're using, Math Olympiad Contest Problems by Dr. George Lenchner. This book is available at the website www.artofproblemsolving.com, and I'm going to be giving homework assignments now that are out of this book. So if you want to follow along with the homework assignments, please buy the book. It's a wonderful book, and the guys who run artofproblemsolving.com I think are really great people. From memory, I think it's about $30. Anyway, here's practice problem number 1. Could you run and get an eraser for me? Here's practice problem number 1. Suppose today is Friday. What day of the week will it be 100 days from now? And what day of the week will it be 200 days from now? I found one, sweetie. Yeah. Okay. Suppose today is Friday. What day of the week will it be 100 days from now? And what day of the week will it be 200 days from now? So we've seen problems like this before. Do you understand the problem?
Yeah.
Okay, what day is it today in the problem?
Friday.
And the question is, what day is it going to be 100 days from now? So you know how to do problems like this. What do we do?
Well, we can count it all the way up. We can try to figure out a pattern and count by sevens all the way up to the highest number closest to 100 and 200.
Okay, so today is Friday. Okay, so you know it's going to be Friday 7 days from now. What else do you know?
14 days from now.
Okay, how can you go even faster?
28 days from now.
Yeah?
70.
70 days from now will be Friday. And then what's going to come after that?
77.
70. 77.
85.
80. 77 plus 7?
86. No, 80. 77 plus 7. 85.
What's 7 plus 7?
14.
What's 77 plus 7?
70 plus 14, 84.
84.
84. And then we get 91.
Right?
And then 98.
Okay, so 98 days from now is Friday.
So that means 99 days from now is Saturday.
Right, okay, right over here now. 100 days from now.
100 days from now is
Sunday. Okay, so we counted by sevens, and we used 70 as something we knew. And then we counted up by sevens from there. Now let's do 200 days from now. So if today is Friday, what's 200 days from now? Okay, so what's 200 days from now? Where do you think we should start?
We could start at 98.
Okay, so we know 98 is a Friday.
98 days
is a Friday. Okay, 98 days from now is a Friday. Good. I'm just going to write the 98. Okay, what do you want to add to 98? Remember, we're trying to get up to 200.
Well, 70 plus 70 is 140, so 140.
Okay, so 140 is a Friday. That's a good place to start.
Yeah, 200. And then you can't fit another 70 in there because another 70 would be 210.
Well, let's do that actually. So another 70 would get you to 210. That's too high, so what do we have to subtract away?
Wait, I have to subtract away 14.
Okay, if we subtract away 14.
So 210 minus 14.
What's that?
It's 198. No, 196.
196. So 196 is a Friday.
And so 197 is...
Oops, sorry. Is it still in the picture? Yeah. That's a Saturday. Sunday. 199 is Monday. And 200 is Tuesday.
Tuesday.
Tuesday with a 2. 200 is Tuesday with a 2.
Yeah.
Yeah. Now, one other thing to notice here, Kogan. Do you see anything, the relationship between 196 and 98?
The difference is 102.
Nope. What's 98 plus 98?
98 plus 98. 90 plus 90 is 180, and 8 plus 8 is 16.
So 98 plus 98 is?
196.
196, that's right. So we could have started at 98 and just did 98 plus 98. Starting at 140 was fine, and then adding another 70 to get to 210, and then subtracting was fine too. Okay, so those are two good problems. So the homework assignment for this one is Olympiad 22, problem number 1. Olympiad 22, problem number 1 out of our book. All right, here's the next practice problem. A rectangular tile is 2 inches by 6 inches. What is the least number of tiles that are needed to completely cover a square region 3 feet on each side? Okay, do you understand the problem?
Yeah.
How big is our tile?
A tile is 2 inches by 6 inches.
2 inches by 6 inches. And how big is the square we're trying to cover?
3 feet on each side.
Okay, great. All right, so we have 2 inches by 6 inches. 2 inches and 6 inches. And this isn't going to be exactly to scale. That means that...
Yeah, it's not going to be to scale.
3 feet.
Or you could just say 1 yard, because 3 feet is 1 yard.
3 feet is 1 yard, that's right. But if we're going to use the same units, what instead of yards, what should we use? Instead of feet or yards, what else could we use? Inches. How many inches is 3 feet?
Well, 12 inches are in a foot.
Right. So what's 3 times 12?
3 times 12 is 36.
36. So the first step in this problem is realizing that 3 feet is the same as 36 inches. Okay. So how many of these 2 inches by 6 inch tiles are gonna go this way? So how many 6 inches can fit across this?
How many 6 inches can fit across 36 inches? 6.
6, that's right. So there's going to be 6 tiles this way. Okay. And how many of these tiles can go down this way?
The same, 6. It's 36 and 36.
Well, how long are the tiles?
Tiles are 2 inches by 6 inches.
Okay, so they're 6 inches long, but how tall are they?
The 6 inches tall. No, 2 inches tall.
They're 2 inches tall. So how many 2-inch tiles make 36 inches?
So 18 plus 18 is 36.
So what's 36 divided by 2?
18.
18. So there's 18 this way. So we have 6 across and 18 tall, so that means we have to figure out what 6 times 18 is.
Well, 6 times 10, I know, is 60.
Okay.
And 6 times 8 is 48, so it's 108.
Okay.
6 times 18 equals 108.
And we figured that out by saying 6 times 10. Sorry, I don't have a lot of room here. And I don't have a working marker.
Shoot!
6 times 10 is 60, and 6 times 8 is 48.
And 60 plus 48 and
is 108. Yeah, that's okay. 60 plus 48 is 108. All right, good job. So in order to solve this problem, we had to figure out how many tiles went across and how many tiles went down. And we also had to convert feet into inches. But we knew how to do that. Okay, so the homework assignment from this one is Olympiad 22, problem number 3. And so you can watch these videos later today, and then you're going to work out Olympiad 22, problem number 1, and Olympiad 22, problem number 3. Got it?
yeah.
Okay, those were pretty fun problems, weren't they?
Yeah.